All right, sample problem 4.11 says that in a simulation, mercury removal from industrial wastewater, 0.05 liters of 0.01 molar mercury 2 nitrate reacts with 0.020 liters of 0.1 molar sodium sulfide. How many grams of mercury 2 sulfide form? Write a reaction table for this process. All right, so again, this is going to be one of those precipitation reactions. So our first step will be to write a balanced equation. So let's see, they tell us we have mercury 2 nitrate. So by mercury 2, they're telling us that has a 2 plus charge. So I'm going to have Hg. And then nitrate, remember that's the polyatomic ion NO3, and it has a minus charge, so I've got to have 2 of those. And let's see, that's an aqueous solution, so it's soluble, right? If we were to check the solubility rules for that thing, it would tell us, that would be soluble. Plus sodium sulfide. Sodium has a +1 charge. Sulfide has a 2 negative charge, so I've got to have 2 sodiums for every 1 sulfide. AQ yields, and remember the cation of one is going to pair with the anion of the other. So the mercury and the sulfide are going to go together, and it's going to be mercury 2, right, with 1 sulfur, solid, plus our sodium nitrate, right? Sodium, a little bit more room there. Sodium nitrate, NO3, and that's going to be aqueous because if we check the solubility rules, all nitrates are soluble, as well as group 1 metals. They're all soluble too, so on both accounts. So now we have to check that it's balanced. I've got 1 mercury, 2 nitrates, only 1 nitrate, so I can fix that by putting a 2 there. So now I have 2 nitrates. I've got 2 sodiums, 1 sulfur, 1 sulfur. So it's balanced. All right, and then the next step is to start by writing what we know. So let's see here. They're giving me information on both of my reactants. So that is my clue that this is going to be a limiting reactant problem. So even if they wouldn't have told me there at the top of this problem that it was limiting reactant, I could have figured that out because they're giving me information on 2 reactants and asking me how much product I can form. All right, so let's see here. If I have 0.050 liters of mercury 2, I'm trying to get in a hurry there. Mercury 2 nitrate. And I need to know, how much of one of my products I can make. I've got to convert that liters to moles. And remember, molarity has units of moles per liter. And so the molarity of the mercury 2 nitrate tells me that in 1 liter of that guy, I have 0.010 moles. And I'll put my mercury nitrate there. Okay, and let's see my units. I've got liters divided by liters. They're going to cancel out. And I can do my math there. And I've got 0.05 times 0.01. And that's going to give me 0.0005 moles. I'll come down here, moles of mercury nitrate, NO3. And I got 2 of those. Okay, and now I can convert to product. Right, I'm looking for mercury sulfide. So if I have 0.0005 moles of mercury 2 nitrate, and I'm wanting to know how much mercury sulfide, remember our balanced equation relates those things, right? Those molar ratios. For every 1 mole of mercury nitrate, I can make 1 mole of mercury sulfide. So let's see, 1 mole mercury nitrate, NO3(2). I can make 1 mole of mercury sulfide. All right, and so let's see, what's that going to equal? I've got moles divided by moles, cancel, and that's just going to be 0.005 moles of mercury sulfide. Yeah, HGS there. And now we have to do the same thing for our other reactant, right? We're looking at 0.020 liters of sodium sulfide. And I've got to first convert to moles, right, using my molarity, and they tell me that in 1 liter of the sodium sulfide, we have 0.10 moles of sodium sulfide, and I'm getting that directly from the molarity. Remember, the units for molarity, moles per liter. Liters cancels with liters. All right, I've got 0.02 times 0.1, and that's going to give me 0.002 moles of mercury sulfide. And I messed up here. I didn't put my extra zero, so I'm going to fix my moles up here. That's actually 0.005 moles of mercury sulfide. So if you'll notice, this is a much smaller number here, right? So what that means is that, I'm going to put a little star right here, that means that my mercury nitrate is my limiting reagent there, or reactant. I can only make 0.0005 mercury sulfide. I can't make 0.002 moles because I'm limited by the amount I can make based on the mercury nitrate. So now that we know our limiting reactant, we can set up our reaction table, which is the next part of the problem here. And a reaction table always starts with the balanced equation. So I'm going to write that up first. I've got See, I've got mercury nitrate plus my sodium sulfide yields mercury sulfide plus my sodium, and I got two of those, sodium nitrates, NO3. And then we set up our table, and we start out with initial concentrations, or initial moles. All right? So let's see. What does the problem tell me I have for the mercury nitrate? The concentration they gave me was, or the moles they gave me, right, was 0.0005. That's what I started out with there. I started out with 0.002 moles of the sodium sulfide, and initially we always start out with 0 moles of products, okay? Because at the beginning of a reaction, they haven't reacted yet to form any products. So then we have the change, which comes next. And here's where we write up how much of the reactants we used and then how much of the products we formed. So let's see. By knowing mercury nitrate was my limiting reagent, I know that I used up all of that. So I'm going to put minus 0.0005. I don't know how much sodium sulfide I used up because, you know, I'm still going to have some of that left. So I've got to figure that out here in a minute. I know that I can make plus 0.0005 moles of mercury sulfide. And I don't know how much sodium nitrate I can make yet either, because we never did do that math, right? We didn't set up a t-table to figure that out. So let's see here. Let's see if we can figure some things out. As far as how much we used up of the sodium sulfide and how much sodium nitrate we made. So if I made 0.0005 moles of mercury sulfide, let's see how much sodium sulfide it takes to make that. So from the balanced equation, I'm going to use that as my conversion factor. For every 1 mole of mercury sulfide, it takes 1 mole of sodium sulfide. And check it out, I got that directly from the balanced equation, right? For every 1 mole, I got 1 mole. So I'm converting here. So that means that I used up 0.0005 moles of sodium sulfide, right? If I check my units, moles of mercury sulfide cancel with moles of mercury sulfide. All right, so that means minus 0.0005 here for the sodium sulfide I used up. And very similarly, we can figure out how much sodium nitrate we made. If I used 0.0005 mercury nitrate, and I set up my T here, for every 1 mole of mercury nitrate, I got 2 of those, I can make 2 moles of sodium nitrate. So let's see, I've got 0.0005 times 2 is 0.001 moles of sodium nitrate, NO3. So let's see, plus 0.001 moles. And now the last part of our reaction table, I'm gonna add everything, tally everything up, and we call that final. So for the mercury nitrate, 0.0005 minus 0.0005 is 0. For the sodium sulfide, 0.002 minus 0.0005 is equal to 0.0015. That's how much of that I'm going to have left. And then I'm going to have 0.0005 of my mercury sulfide and 0.001. So at the end of the reaction, right, that's why we call this the final. I'm still going to have some of my sodium sulfide left because it was my excess reactant. I'm not going to have any mercury nitrate left because it was my limiting reactant, right? We used all of that up. And then that's the maximum amount of product I can form, right, based on my mercury nitrate.